Hey folks, so in the next series of videos, what I want to introduce is a few graph theoretic applications of the algorithms we've been talking about, BFS and DFS. So the first one I want to talk about is connected components. So this is actually a term we introduced way back in the first video for this module. So the idea here, right, is I have a graph and I may want to ask the question, is part of the graph connected to another part of the graph? So here, just looking at my picture, I have a little graph at the bottom of the screen. I have basically two components to it, right? There's no way to get from one side of the graph to the other side of the graph, right? So if I'm on the left, I can't get to the right. If I'm on the right, I can't get to the left. So what we want to do is basically investigate this, right? It would be nice to have an algorithm that basically, if I looked at a graph, it could tell me how many components there are and what component a particular node was in, right? So basically what I want to do is I want to have a way to generate this picture on the lower right-hand side from my graph. And so this has, some applications. Obviously, there's applications in terms of like networking, right? So it's like, well, if I have a graph that represents, on my computers and how they're connected together, I could basically run this algorithm on it, and it would tell me how many different like little networks I have, right? Independent networks are available, right? So there are definitely some good applications for solving this problem. So we have already, right, kind of defined our API. So up top, I have the API that has my standard things, right? So obviously, I need to have an instructor that I give it a graph, and I can go and analyze that graph to go and find the connected components. And then I can basically check to see our two things connected, right? So is there a path between V and W? This is kind of another connectivity thing. It's a little bit like the sense of doing the marked node, but more general, right? Are two things connected? I'm not baking in a start position. And then, how many components are there? What particular component does a node belong to, right? So these are going to be the four different things we want to try and implement. I probably should have mentioned before, but just to remind you, right, the idea of a connected component or a connected graph is basically that from any node, there's a path to any other node, right? So that's what we call a connected graph, right? Is if I can get from one place to any other place. We use the term connected components because sometimes an actual graph gets broken down to multiple components where within the components everything's reachable, but then I can't get from one component to another, right? So that's what the picture is showing, is I have two different components. I can't get from one side to the other. I have to, treat those as being isolated. All right, so this is the problem we're trying to solve. Question for you guys here, and you can think about it for a second, is given that we have all this functionality from our different BFS and DFS, how could we maybe try to solve this? Is there anything we've seen that could give us the connected components? So think about that for 1 second. Okay, so you could actually use both BFS and DFS to do this, right? Because if you think about it, what we could maybe think about doing is doing something like, hey, run DFS, basically just start DFS from some node and see where it reaches, right? Wherever it reaches is going to form a connected component because it's basically, well, it's an undirected graph, so if I go explore forward, I can explore backwards as well. So if I go and do a DFS, basically everything that I discover makes up a component, right? So I could maybe think about doing that. The problem is then I do a little bit extra work because, well, hey, I may have more than one component in my graph, but I can at least start there. All right, so having said that, let's jump forward and actually take a look at some source code that does this.